Having seen how to write Haskell programs, let us now look at how to run them on the computer. The easiest way to run a Haskell program is to use the Haskell interpreter GHCI. Using GHCI will be very familiar to people who have used languages like Python. So GHCI is an interpreter. You load GHCI and then you can interact with it. You can directly call built-in functions, or you can load user-defined Haskell code which you have previously entered into a text file. GHCI is freely available on the internet. The easiest way to get GHCI working on your system is to download what is called the Haskell platform from the web URL given here. So here is a screenshot of what the Haskell platform website looks like. As you can see, you can download versions of the Haskell platform for any operating system, for Windows, for Mac OS, and for Linux. So how do we actually use GHCI? Well, we first create a text file with the extension .hs to indicate that it's a Haskell file containing your Haskell function definitions exactly as we wrote them in our previous lecture. Then we run GHCI from the command line. Inside GHCI, you can then feed it further commands, and the most basic command you need to know is a command to load Haskell code. This command is written as :load followed by the file name. Note the use of colon. So colon is an indicator to GHCI that it has to perform some internal action. Anything without a colon is interpreted as a Haskell function that it must evaluate. So in this way, you can interactively call functions from within GHCI. Let us look at some examples. So here is a command window in a Unix-like system. So in this we have already created some text files, but let's start from scratch. So supposing we want to create a version of the factorial program. So we open an editor like VI or Emacs. So let us say VI factorial.hs. So this is the first factorial program that we wrote. So there is an error, so let us fix that. So it says that the type of factorial is int to int, factorial of 0 is 1, and factorial of n is n times factorial n minus 1. So now we can exit from the editor, save the file, and load GHCI. So GHCI will load up and give us a command prompt of its own, which in this case is with the prefix prelude. Now we can load the file that we just created using the :load command that we discussed. Okay, and now if all is well, you will get a message like this saying it's okay. Having done this, we can now ask it to evaluate versions of factorial, like factorial of 7 is 5040, factorial of 5, if you want to check a familiar number, is 120, and so on. You can also evaluate built-in functions. For instance, you can ask 4 plus 5, so you can use it as a calculator. This is pretty much how you use it in things like Python. You can say true or false, okay? Or you can say div 7.3. So it's very similar to the Python interpreter if you use that, in that you can invoke any built-in function or any function which you have defined in the file that has been loaded. As we will see, one of the things that you cannot do in this, which you can do in a Python interpreter, is to define functions here. So I cannot write a new function here which says something like square x equal to x star x. So this kind of a definition, which is allowed in Python, is not allowed in the interpreter. You have to write this in a separate file and then load it. So as a shortcut, for instance, you can use :L instead of load. First of all, you say :H, you get a list of all the possible commands that you can do in GHCI in case you want to investigate. But :L is a short form, so I can say :L factorial.hs, and now it will just replace the old factorial by a new factorial. The other thing is that you can query types. For instance, I can now ask what is the type of factorial, and it tells me that the type of factorial is int to int. So if you have a function which whose type you are unsure of, you can ask this, but beware that the types reported here can be more complicated than the types we have seen. For instance, you might ask what is the type of a number 5. Okay? The number 5 you would expect has type int, but actually it gives you this complicated thing which says num a and a different type of arrow with a. So we will see later what these things mean. But for functions that you define, you can verify that the types are indeed what they say they are. So let us get out of the interpreter for a moment. Okay? And now let us look at this factorial that we wrote, so I have got the same code in a file called factorial positive. Okay. And this is to indicate that this factorial handles only the positive case. So this is the same factorial we just used, except I've added now a comment. A comment in Haskell starts with 2 hyphens on in the first 2 columns of the line. Right? So the first line is a comment which says this is a factorial that does not handle negative inputs, which we already know, but let's see what it does. Right? So if I go back to GHCI, right, and I load this factorial positive and I ask it to do factorial, say -1, then as we would expect, it goes into an infinite computation of factorial -2, -3 and so on, because we have not handled the negative phase. And the only way to get out of this is to physically break the program from running. And one way to do this is to use Control C or Control D, or nothing works, unfortunately. Okay. So you have to figure out a way to abort the program. Okay. So, so now instead we have written a better version, which we had done already in the class, which said if n is less than 0, then you negate the factorial. Okay? So now, so this is not with a pattern match here. This is a factorial with negative inputs. So now if I load this version, and now if I say factorial of -4, for instance, then it will convert it to +4 and give me factorial of 4. Now we also saw that we could have this kind of factorial function where we have made a mistake, right? So instead of n greater than 0, we have written n greater than 1, and this says that there will not be any case when factorial 1 works. So let's see what happens when we load this. So now if I say factorial of 0, it doesn't go into the problematic case, so it's fine. But if I say factorial of 1, then I get some kind of pattern match failure. Okay? So it says it's an exception, factorial fail, and so on. So the actual error message depends on the version of GHCI. The error message written on the slides is slightly less expressive than this. Right? So you get some kind of error message. And now, finally, we have also written a version of the XOR and the OR that we did. Okay? So we have XOR and an OR. Now, here we have another problem which comes up and which you should be aware of. So if I say load Boolean, okay, now if I say XOR of true false, there is no problem. But if I say OR of true false, then I get an error message saying that it's confused by the word OR, because the built-in symbol for OR is the 2 vertical lines, but OR as an English word can also be used in a Haskell program. So OR is a built-in function, and it says that the built-in function OR is in conflict with the OR which is defined in this file. Now, of course, one could say main.or as it suggests. So main is the version that we have just loaded. Okay? Or even better than this is to actually go back, okay, and edit the file and use a new name. So it's conventional to use the prefix my. So whenever you have a function whose name looks like a familiar function, it is best to rename it with something which distinguishes it from the familiar function. So that now if I load this and say my or true false, it will work fine. Okay? So we have seen how to load files into the interpreter. Some kinds of error messages that you see, you can also query types. Okay? So it's very easy to use this interpreter, and it's quite Haskell programs tend to be small, so it's not very difficult to debug them, as we will see. So please get familiar, do download DHCI onto your system and start playing around with it. So as we mentioned when we were showing the use of GHCI, one of the differences between GHCI and Python is that you cannot create function definitions on the fly. So within the interpreter, you cannot define a new function. You must load it as a separate function from an outside file. So you must first create a .hs file and then load it into the interpreter. Right? So this is an interpreter, but Haskell also comes with a full-fledged compiler. So GHC is a compiler that creates an executable file from a .hs file. So GHC stands for the Glasgow Haskell compiler, and GHCI is the associated interpreter, which is the one that we have seen. Now, unfortunately, we cannot use GHC directly on the Haskell functions that we have been writing. We need some more advanced concepts, which we will see as we go along. So at some point, we will start compiling our code, but for the moment, we will just stick to GHCI, the interpreter. Okay, so to summarize, the easiest way to run Haskell code is to use the interpreter GHCI, which is quite user-friendly, and in which we can load and interactively execute user-defined functions. There is an associated compiler called GHC, but we need to know more Haskell before we can use it.